Let's look at this one real quick. Uh, Primary voltage on the line is 21 kV, and so yeah, first thing I look at is the kVAs. They're the same, but let's say this one were to be bigger. Well, then this would be the lighter can. What's a lighter can? Well, that would be the transformer that provide light and power. You'll see some of those in there, and then down here, if it says for you to ground a corner ground, whatever, then you have to ground it and you have to show it. Okay, you have to show, just make an arrow, this is the leg that I grounded or whatever. On a delta, you're allowed to ground one corner. Okay, if you can't ground more than one, like A, B, C, it doesn't matter. You could ground A or B or C, it doesn't matter which one, but only one. On a Y, you cannot ground a Y leg. Okay, but anyhow, I already drew this out, the Y and the delta, but because I can't draw a straight line without two hands. But anyhow, these are the same. Impedance are the same. There's no problem. Okay, if you have a three-phase bank, you want the impedance to be similar. I think it's like 1.2 is the much you can have. But anyhow, just look at the primary, the first number, 21 and 12. They're not the same, so it's a Y, right? And then your secondary, you look at your second number, which is 480. In this case, there's only one. Okay, there's only one. There's no number behind this. So like 480, and you got 480, right? So write your PS. Okay, so look at this coil. You're gonna get 480, and they're already there. It's already in series, right? It's already done that for you. It's already in series. But in order for your coil to get 480, you have to take this whole thing. That's what the customer wants. The customer don't want 240, right? They want this whole thing, right? If they wanted 240, we're gonna have to ground one of these or whatever. But in this case, it's gonna have to be a delta, the secondary. It's gonna have to be a delta because they're using this entire thing. If they were to use a Y on this, then all these would have been grounded right here. Those would have been grounded, and that wouldn't work because you got phase to ground, which is, yeah, you'll get 480, but then phase to phase would be something else. It would be 1.73 times 480, but they don't need that voltage, so you're going with delta. So your secondary is delta and your primary is Y. So your Y start at 330, and then 120 degrees would be up here, and then 120 degrees away would be here. So you write your capital A, capital B, capital C. You're going from high to low, make your arrows. You're going from H1 bushings to H2 bushings. H1, H2, right? This line represents transformer 1, this line represents transformer 2, this line represents transformer 3, H1 to H2, right? So your secondary is going clockwise, right? And this is your A phase, your B phase, your C phase, right? And it's going from X1 to X3, always from X1 to X3, no matter what, even if it's subtractive or additive. X1, X3, X1, X3. And your transformer 1, this is still transformer 1. And this is transformer 2, because you see how this is parallel with that. And this is parallel with that. And that is parallel with this. So this remains, no matter what you do. That's why you have that 30-degree displacement right here, because delta delta, you know, your lines, they're in parallel. They don't, you know. But when you go from delta to Y, you have to shift it 30 degrees in order for this line. No matter what you do in vectoring, your T1 here has to be parallel with T1 in your secondary, and your T2 in your primary has to be parallel with T2. You see what I mean? So anyhow, let's hook this up. Let's do the primary first. what's going into T1 in H1 bushing? A phases, right? Make a dot right there. Okay. Then what's going into T2? B phases, right? And what's going into C phase? T3 is your C phase, right? To be continued.